Hello friends, welcome to my YouTube channel Make Maharashtra. Will gives you more educational videos. I hope you are sharing, liking my videos and do subscribe for this channel. We have seen the geometrical relation for open and cross belt drive. Now next point will be the creep of belt. Now first of all, understood what is creep. So I'll say, just listen it. The creep is nothing but when belt passes from slack side to tight side. You can see this is slack side and this is tight side. Now listen carefully. When belt passes from slack side to tight side, from here to here, a certain portion of the belt extend and it contrasts again when it passes from the tight side to slack side. Due to these changes, what happened? Due to changes of this, there will be the relative motion occurs in between belt and pulley surface. So this relative motion is called as a creep. Clear? When belt is passes from the slack to tight side, there will be some extension in between the part of the belt, and again it will passes from tight to slack side. It will be the contraction. So this chain will be there, and because of that, the belt and surface motion, belt and surface of the pulley created the relative motion. So that relative motion we can say as a creep. Understood? So that's why I have shown the diagram. Now this will be the creep. Now generally, so see in the short, the slack, when belt is moving from the slack to tight, it can be extend some part of the belt, and again it will be moving from the tight to slack. There will be the contraction occurs in between the belt. So this relative motion with respect to belt and surface of the pulley is called as a creeping. So creeping is calculate, see, N2 by N1, that is RPM of second pulley divided by RPM of first pulley, is equal to D1 by D2. You can write this equation in our case also. Likewise, see, I'll write the capital N for bigger pulley, small n for smaller pulley, which is equal to small d divided by capital D in bracket E plus modulus of elasticity, or Young's modulus we can say, plus stresses in second divided by stresses in first. So likewise you can write. So equation would be this. Just remember, N2 by N1 is equal to D1 by D2 into D1 and D2 is nothing else, smaller and bigger pulley, that's it, into modulus, Young's modulus E plus sigma 2, sigma 1 and sigma 2 stresses occurs in the tight side and slack side of the respective pulley, that is sigma 2 by sigma 1 square root. So this would be the equation for creeping. 8 exam also such kind of the questions, one formula based question ask. Clear? The creeping. Okay. Next point, the belt tensions. As I told you, the tension on tight side and slack side. So just see here, dear friends, the somewhat notations are different here, because here in this case D1, D2, N2, N1. No need to confuse, because the smaller and bigger pulley we need to consider here, nothing else rather than that. So no need to confuse here, because I have referred many reference book for delivering this session. So don't worry, just understand the things. Now here see the belt tensions, you can see tension on tight and slack side. So generally many books refer tension on tight side T1, tension on tight side T2. Clear? So here many books they have referred TFT, tension on tight side, TFS, tension on slack side. So don't confuse here. So I can write here this equation, T1 by T2 is equal to e raised to mu theta also. No worry. Clear? So this equation also write in the logarithmic format, that is 2.3 log of T1 by T2 is equal to mu theta. Likewise also we can write through which we can calculate belt tensions. What is the power to be transmitted? How much amount of power is transmitted by the belt? I think you have studied this in the BME, basic mechanical engineering, first year. So power is calculated, that is work done per second is equal to T1 minus T2 into velocity. So the equation is power is equal to T1 minus T2 or TFT minus TFS into VB, belt velocity. This V is nothing but V, belt velocity. Many books have referred VB also. So don't confuse, directly the relation is same everywhere. So the work done is directly coming, that is T1 minus T2 into belt velocity. Clear? I told you the three equations. One is the creep, second is the belt tension, two equations, and power to be transmitted T1 minus T2 into velocity. Clear?